Section A of our first internal data science. So question 1. Measure of dispersion. Give three more commonly used statistical measures for characterizing dispersion in student feedback data. Example, variation in teaching quality scores, lab facility ratings, or peer collaboration effectiveness. Discuss how these measures can be computed efficiently in large student databases. So first is range definition. The difference between the maximum and minimum values in the dataset, computation efficiency, highly efficient big of one once the maximum and minimum values are known in a streaming database. These two extreme values can be tracked in a real time with minimal overhead. So question 2, interquartile range IQR definition. The difference between the third quartile Q3 and the first quartile Q1. It measures the spread of the middle 50% of the data, making it robust to outliers. So computation efficiency requires of finding the 25th and 75th percentile in large databases. This efficiently approximate using quantile sketching algorithms like the Greenwald-Khanna algorithm, which maintain a summary of a distribution using very little memory and allow fast approximate quantile retrieval. So third is variance and standard deviation. Definition of variance is the average of the squared differences from the mean. Mu standard deviation sigma is the square root of the variance. It indicates how spread out the data is relative to the mean. So formula of variance is equal to summation of I summation of xi minus mu to the power square from I is equals to 1 to n divided by n. So computation efficiency, the formula requires two passes over the data, one to calculate the mean mu and second to calculate the sum of square differences. This can be solved efficiently in a single pass using Welford algorithm, which is maintain running totals for the mean and the sum of the square differences, making it ideal for large streaming datasets. Question 2, feedback rating analysis. So suppose faculty student feedback rating on a scale of 1 to 100 on faculty mentoring effectiveness is given in sorted order. So here we have given rating of faculty in sorted order from 13, 16 to 70 in the range of 1 to 100. So question 2, what is the mean rating? To calculate mean rating, we use this formula summation of x divided by n. So summation of x is equal to 580 and divided by n. N means the total number of ratings, which is 20. So 580 divided by 20 is equal to 29. 29 is the mean. The average faculty mentoring effectiveness rating is 29. So what is the median? Calculation. The median position for n is equal to 20 even is the average of the n divided by 2 is equal to 10th and the n divided by 2 plus 1 is equal to 11th value. So 10th value is 33 and 11th value is also 33. So the median 33 plus 33 divided by 2 is equal to 33. So what is the mode of the data? To calculate mode, the mode is a value that appears most frequently. The value 20, 33 and 35 each appear twice. So mode is equal to 20, 33 and 35. So second kadi, comment on its modality, bimodal, trimodal, etc. Comment that the data set has three models 20, 33 and 35. Therefore, the distribution is trimodal. This suggests that there are three distinct groups of students with a common sentiment level towards mentoring effectiveness. So second guy estimate the first quartile Q1 and the third quartile Q3. Calculation first quartile position P 0.25 is equal to 0.25 n plus 1. 0.25 into 21 is equals to 5.25. So Q1 is equal to fifth value plus 0.25 into sixth minus fifth value is equals to 20 plus 0.25. Bracket 20 minus 20 is equals to 20. Third quartile Q3 position P 0.75 is equals to 0.75 n plus 1 is equals to 0.75 into 21 is equals to 15.75. So Q3 is equals to 15th value plus 0.75 into 16th minus 15th value is equals to 40 plus 0.75 into 45 minus 40 is equals to 40 plus 3.75 is equals to 43.75. Second का if given the five number summary of the ratings summary, the five number summary provides a robust description of the dataset shape and spread. Minimum is equals to 30, Q1 first quartile is equals to 20, median Q2 is equals to 33, Q3 third quartile is equals to 43.75 and maximum is equals to 70. So draw box plot of the data. As an explanation of box plot, the box plot displays the five number summary graphically with the box spanning the IQR Q1 to Q3 and the line inside marking the median. The whiskers extend to the mean and max unless outliers are present. Second, second, how is a quantile plot different from a quantile plot in the context? So quantile plot, Q plot plots the value in the sample dataset against their corresponding quantile range or z-score divided by percentiles in the dataset itself. It primarily shows the overall distribution shape and helps identify clusters or tails. So quantile plot, QQ plot, plot the quantile of the same dataset, our student rating against the quantile of a specific theoretical distribution, usually the standard normal distribution. So difference in context, the QQ plot is used especially to test for normality. If the plot points on the QQ plot fall approximately on a straight diagonal line, the student feedback data can be assumed to be normally distributed. If they deviate significantly, the data is non-normal. So question 3, approximate median score. Suppose student lab infrastructure satisfaction scores are grouped into intervals with the following distribution. Compute an approximate median satisfaction score for the student. Here is the score range and here is the frequency. So step 1, calculate cumulative frequency and total n. So score range 1 to 5, 6 to 15 to 81 to 1110. And here is the frequency and the cumulative frequency. And then step total frequency n is equal to 3194. Step 2, identify the median class. Median position n by 2 is equal to 3194 divided by 2 is equal to 1597. The class where C1 first exceeds 1597 is the 21 to 50 range. Step 3, apply the median formula. Median is equal to L plus n divided by 2 minus C upon Fm into W, where L is equals to lower limit of median class which is 21, n divided by 2 median position which is 1597, C is equals to cumulative frequency of preceding class which is 950, Fm is equals to frequency of median class which is 1500, W is equals to class with which is 29. So calculation median is equals to, we put this value in this formula and got 33.51. So the approximate median satisfaction score is 33.51. Now question for age and productivity analysis. In the Department of Lifelong Learning, a feedback survey collected both student age and their self-assessment of learning productivity for 18 students. So here is the age and here is the productivity. So for calculate the mean, median and standard deviation of age and percentage productivity. So age x calculation mean. Here we calculating mean which is summation of x is equal to 864. X is equal to 864 divided by 18 is equal to 448 years. In median sorted age. So here is a sorted ages and median is equal to 50 plus 52 divided by 2 which is 51 years. And standard deviation is equal to summation of x minus x power x square which is 4786. So variance summation of x is equal to under root of 4786 divided by 18 is equal to under root of 265 rotated which is 16.31. So productivity y calculation mean y is equal to summation of y is equal to 548.8. So y becomes 30.49. In median, so in sorted here is given in a sorted order. Median is equal to 29.5 plus 31.2 divided by 2 which is 30.35. The standard deviation, so y minus y square is equal to 2.2062.92. So variance of y is equal to 2 point under root of 2062.92 divided by 18, which is equals to 10.70. So for if there is fourth B, draw the box plot for both. Explanation. Two separate box plots are required to visually compare the central tendency, speed and symmetry of the agent productivity distribution. Here is the fourth C. Draw a scatter plot and a QQ plot to study the relationship. Scatter plot relationship plots age on the x-axis and productivity on the y-axis. The resulting graph reveals the correlation and potential clusters or outliers. So, a QQ plot distribution check used to compare each variable's distribution against the theoretical normal distribution. Thank you for watching.